about common emitter amplifier, correct? Today we are going to start the remaining portion. Today we'll finish off. Today finally we'll complete the common emitter amplifier and common source amplifier. In the syllabus I have given topic names as first topic. BJT models I have given first topic. That is 3 models we have studied. One is hybrid parameter model. One theory we have studied, and one more theory is called RE theory. We call it as biasing theory. And one more theory is arc theory, which is called BJT theory. After understanding these 3 models, second topic we have gone for MOSFET design called MOSFET amplifier model. That is the second topic we have studied. After that we have gone to common emitter bypass, and in that lambda equal to 0, lambda not equal to 0 cases, and VA equal to infinite, VA not equal to infinite cases we have seen. Lastly, one more special amplifier is the common emitter unbypassed amplifier that I tell you. So bypass means there will be no negative feedback. RE will be 0. Unbypassed means we are keeping the feedback in an AC analysis. Then what happens to your characteristics? That is observation. Okay. Let us start. Good morning, Kamlesh and Vishal. Very good morning. Let us start the class. So common emitter unbypassed. How to write? Common emitter unbypassed. Common emitter unbypassed amplifier. So what is the difference between previous topic and present topic? You can see bypass unbypassed difference. Here we have RE, we have RC, we have divider R1 R2 as a biasing circuit, R1 R2, coupling capacitor CC, you have VIN, and we have coupling capacitor CC2, CC and V0. This is VCC. So one thing you can observe clearly, what is the difference? You can see in the diagram. Common source unbypassed amplifier. Same design for common source unbypassed. We have RS, RD, R1 and R2. Coupling capacitor CC, this is VIN, this is VDD, this is your output. So you can see 2 amplifiers I have designed. So just note on it, these 2 designs. One is common emitter unbypassed, and the other one is common source unbypassed. So what is the difference you can see in between these 2 amplifiers? Common emitter unbypassed and bypass is the previous class we have RE parallel to CE. That means bypass capacitor we kept. So that in AC analysis RE will get shorted. So RE will not influence the circuit in AC analysis. But in this topic we have removed the capacitors. Here we remove the bypass capacitor. There also we remove the bypass capacitor. That means the circuit will behave as a negative feedback circuit, which is called as a closed loop amplifier we can call. Okay, this is behaving like a closed loop amplifier. Whenever the system works as a closed loop amplifier, it will have different characteristics compared to the open loop amplifier. So previous class is open loop, now present class is closed loop. So let us see what is the points here is. Condition for unbypass is condition. What is the condition here is? Point number 1, CE should be removed in the circuit. CE should be removed from the circuit. This is first point. CE should be removed from the circuit. If it is a MOSFET, it is CS. It is a BJT, we call CE. CE should be removed from the circuit, called as bypass capacitors to remove. And second point is, in AC analysis, your RE should not be equal to 0 and RS should not be equal to 0. This is the second point. So first CE you have to remove from the circuit, and you should see RE value should not be 0. Sometimes what happens, if there is no capacitor also, we can make it short directly. That is not unbypass. Unbypass means capacitor also you have to remove. At the same time you have to keep the resistor also there. Okay, that is called recognition of the unbypass system in electronics. So these circuits will behave as a closed loop amplifiers. Why I said closed loop means we applied the negative feedback to these amplifiers. We applied negative feedback. That's why I got the name as closed loop amplifier. So in common emitter, always in analog electronics, 2 types of amplifiers we can design. One is open loop amplifier, one is a closed loop amplifier. So previous class is open loop because RE is 0. Present class is a closed loop. Okay. Any system have feedback, we call it as closed loop system. So it will behave like a closed loop amplifier. Today class our interest is which is advantage generally that we'll understand. By investigating the characteristics, finally we'll try to give a conclusion whether closed loop amplifier in common emitter is better or a open loop amplifier is better. That is the analysis today. Okay. So please complete up here. Today I think only 2 messages I have seen. Kamlesh and Vishal only said good morning. What about the other students? You have taken holiday today? Today October 2nd. I think in my office also most of the people have taken holiday. Okay. I think in the office, I think at this present moment I only teaching now. The other people are in holiday. I'm expecting you also taking holiday, most of the students. So if you are present in the class, just give a message good morning so that I can understand whether the students are there or not, at least. So just respond with a good morning so that I can understand whether students are listening the points or not. So please complete up to here. So today I think just 15 minutes I became late because nobody is there in the office. That is the reason some 15 minutes delay happened. I'm ready always by half an hour before for any class. My discipline is like that. Okay. I'll be always disciplined in my classes. Half an hour before only I'm expecting to ready for the classes due to some of these problems. Maybe sometimes delay will happen. Chat box is working or not? I think I'm not getting any messages. I think I have to refresh it one time. So please complete meanwhile. No internet. It's creating a problem with internet. Internet problem is coming. Creating always problem here. Now keep hotspot now. Let us see. Hotspot is ready. So let us see the messages. Now it's coming, everybody's telling good morning. Thank you very much. If you don't tell like that, I'll not get a feeling to start the class. So I think due to net problem, I think I have not received a good morning from everybody. So, yeah, Arpita, now it is visible here due to some, I think net problem is there. So hotspot I have opened. Now I'm seeing every messages. Great. I think you are in class. You're not taking holiday. Great. Anupam Das, you are telling so many good mornings. Thank you very much for that. Thank you. So let us start our journey. Okay. Today by 5 o'clock we'll reach the subject of common emitter and common source. So please complete this one. Now we are in track to start the class. So please complete these two amplifiers. Yeah, Samresh, definitely you can understand it. There is no problem. Samresh, you can start recording, what you can say live, you can listen. And after this class, just listen that previous video, okay? Because the only thing is model. I think you don't know the model. That's why you may get confusion. There's an interlink I'm teaching from yesterday class. Oh my God, Arpita, you're very sincere here. If it's high fever for you, please take rest here, no problem. Evening you can see this recording video. Take rest, Arpita. If you have that much fever, please take rest. Otherwise, the fever will go high. Recording video takes it up because evening 5 o'clock I stop the class. So night you can see. Take some rest. Arka Mundal, I think 1 p.m. to 9 p.m. so that the morning you will get a chance to practice. Okay. Let us think about this. Mundal, we'll think about this from Monday onwards. Let's see. Today, tomorrow we'll make it like this, and Monday onwards we'll stay in the time if you want. Okay, we'll try it. And I have asked the other students also. Okay. So if you complete this one, RE and RS, it became a closed loop amplifier. So let us start our first design today. Keep the heading common emitter, unbypass. Common emitter, unbypass amplifier. First we'll separately learn common emitter, unbypass amplifier. For the case of VA is equal to infinite, we are studying the class. That means theoretical study we are doing, or ideal study we can say. Common emitter, unbypass amplifier. As LV voltage is infinite, the model you can see from yesterday to today, what is the difference? You can observe it. Yesterday my model is R pi, and we have here GM into V pi, and this is your collector. This is base, this is collector, and this is emitter. So if you observe carefully the class, very carefully, emitter in previous class it became direct ground because RE is shorted to ground, so RE became 0. But in this lecture he is telling RE is present. So from emitter to ground there is one RE extra. That's why I have written like a model like this. Emitter is joined to this input branch, output branch. Just only thing is, whenever unbypass is there, you just keep on tail like this to emitter side, called RE. So in closed loop system, this RE is impacting the circuit. Emitter to ground there is RE for unbypass systems. The remaining things are same. What we studied yesterday class is same. That is, biasing resistor will come parallel. RP will be connected like this, and this will become your input, and this will become your load to ground. So this concept is common thing for us. RC is ground. This is your output. Can you see that? This is the difference between our previous model and present model. Common emitter bypass model, we don't have this. Now presently it is coming. The remaining things are same. RB will be here, RC will be here, everything is same. So first you have to understand the model design. So after getting this knowledge, you can see here, there is a current flowing here is base current. This is IB, and there is a current flowing here is IC current. This is IC current, and this current we call it as IE current. These are your AC currents. IB, IC, and IE currents. Somebody asked me, can you tell me what is the input impedance of your transistor? He's not asking input impedance of amplifier, he's asking input impedance of transistor. So if I ask you, suppose my input impedance from here, which is your input impedance from the base. Examiner will ask you from the base, can you tell me the input impedance? And from the circuit, we call this as ZIN. So we can define two answers now, ZIN and ZB. ZIN if you want, this will become II. So first we'll finish the answer for ZIN. What is ZIN here is, it is RP parallel to ZB is the answer. RP parallel to ZB. The ZB in previous class it became R pi directly. But now it is not R pi, it is having some RE also here, some impact in the board. That how to find out that ZB is the concept. First answer is clear, R being parallel to something impedance is there, but that impedance will come from here to here now. Because of that RE, we are getting R pi plus some extra quantity. How to find out that answer? Let's see. Okay. Yeah, most of the students are telling morning is better. Morning is better. Okay, morning only better they are telling. So we'll go according to that only. Who is that? So ZIN will be RP parallel to ZB. So what is ZB here is? ZB, it is your input VIN divided by IB current is your answer. From here to here, you have to find out the input. So this input we can write from here to here also. This is total input from here to here. This input divided by base current will be the ZB. What is input current here is IB into R pi. This is one voltage drop. IB into R pi plus IE into RE. This is another voltage drop divided by IB will be the ZB. This is the way how these people are solving this question. So let us take IB common, but this IE current we are getting. So IE you can convert into IB. So we can write ZB as VIN divided by IB. You can write it as IB into R pi plus IE you can write as 1 plus beta into IB into RE divided by IB. Just now you can cancel that IB to get the ZB answer. Okay. This is a simple way of understanding the simple derivations. So ZB you can write it as simply IB if you take common, it becomes R pi plus 1 plus beta times of RE divided by IB. IB is cancelled. So the ZB is R pi plus 1 plus beta times of RE. If you clearly observe this point, this is the input impedance from the base of your transistor. So this is for common emitter unbypass. Common emitter unbypass input impedance. Previously our input impedance is only R pi. Now it has been increased by a factor of 1 plus beta times of RE. In the exam point of view, some theory questions will be there. have high input impedance compared to a open loop amplifier is my idea. So if you see side by ZB is coming only R pi, in case of common emitter bypass. By comparing these two things, you can understand which amplifier is giving more input impedance means common emitter unbypass amplifier will give the more input impedance because of that extra RE effect. RE resistor is there, that's why you get high input impedance compared to the common emitter bypass. Then which is better? High input impedance is better or a low impedance means a person should know the ideal characteristics of an amplifier. If you see here, the ideal characteristics of an amplifier should be ideally your input impedance should be infinite is important for an amplifier. So to solve certain problems like loading effect in coming classes, that property is very important for an ideal amplifier. That's why op-amps has been designed in such a manner it will give high input impedance. So I think high input impedance is better. From these two amplifiers which is giving high input impedance is ZP is giving the class. ZP of common emitter unbypass is giving more input impedance compared to this one. So I think this will become a drawback for you. This becomes a drawback, bypass, but this becomes an advantage because you are increasing the input impedance of your transistor. So that is the reason why this became interesting for applications. This is more interesting rather than a bypass amplifier. So unbypass is more interesting because of one important property called high input impedance analysis. Okay, it is matching with your ideal characteristics of your amplifier. So this is my first understanding about the concept of input impedance is completed. This is my input impedance. So please complete it. Let us see the output impedance, how to do it is the next step. Let us understand output impedance. The next parameter is output impedance. This is not a big idea here, simple concept. Okay, R pi plus, don't write never R pi plus RE because R pi is a resistance for base current. RE is a resistance for emitter current. If you want to increase that resistance for base current, it should multiply by 1 plus beta times. Have that knowledge. Straightforward you can write. Yeah, Pandit, this type of concepts I'll tell you, pi model when to use, T model when to use, H parameter when to use. In the problems I'll explain you. Examiner how he is asking and how to deal. Afternoon class I said, after completion of my protocol course, I'll try to explain you the angle of thinking, how to do it. If I don't teach that thinking, you can't do problems again. Okay? There are certain thinking we have to do. The logics I'll tell you in the practice of how to do problems, don't worry. First complete the content. So Ananya, maybe tomorrow we'll start the class around 9 o'clock, we'll start morning. Okay? Not 8 o'clock, tomorrow is Sunday, we'll start at 9 o'clock tomorrow. Yes, Sri Krishna, same problem for me also. I have good internet connection here, but मेरे को भी same problem आ रहा है. That's why I have gone to hotspot. So change your internet connection otherwise. So can I move to the next step? So be fast in writing. Be fast in writing. So with this we have been completed the first concept called input impedance knowledge. Okay. Yes, sir. Shabani, for ideal amplifier, input impedance generally we take infinite. Why we take? These reasons I'll explain it. Op-amp analysis. Here I'll tell you. Here I don't want to tell you any stories. Only I'll say the marking for you that input impedance should be infinite is required. Why it is required will be taught for you in the coming classes. Yeah, Akash Mitra, definitely. I'll change the time to 9 o'clock. Okay, it will be convenient. I'm expecting. Yeah, Divya, das I have not forget that GM equal to 1 by RE story. Compulsory and teach you. A topic होने के बाद I'll use the conclusion for. Okay. A topic होने के बाद just message me one more time. I'll explain. So let us go for output impedance calculation. Second one is output impedance. Output impedance. We want to calculate as Z naught. So you have some rules to find out output impedance, correct? What are the rules here is your VIN should be 0 and load should be infinite. This is the conditions every time we are applying. Let us apply the conditions in your model. This is ground. This is ground. Next we have is R pi. Next we have R pi. Next we have a current source. GM into V pi. Next we have some RE. This is ground. Ground. We have here RC. This RC we generally will take it as. From here we'll calculate by removing this load for some time. Your RC is infinite. You consider for some time. And calculate the impedance from collector by taking some notation here, Z0 dash. Z0 dash calculate first. Then we can make Z0. So from collector point, what is the output impedance you are calculating? At that time, your input voltage will be 0. So your input is 0 I kept. Okay. Whenever input is 0, this RP will be grounded. RP will not be seen by you because no current will flow to RP. So we have only R pi, we have RE, GM into V pi. Just remove the load for some time, calculate before the load what is happening. This is the way how to practice the calculation part. Okay. So let us start analyzing this Z0 dash how much. This current will take it as some I0. This current will take it as I0. And this voltage will take it as V0. Okay. So can I have one current this side as V pi by R pi. You can have a current. This is V pi by R pi current. And this is GM into V pi. This one current is GM into V pi, this is V pi by R pi. And we'll take this current as this, we'll take it as emitter voltage. So VE by RE will take this current. So there are 3 currents going at the VE point. So can I have a KCL? First we'll apply KVL here. If I apply KVL here in this loop, this is VE voltage, emitter voltage, and this is V pi voltage. If I apply the KVL at the input loop, V pi plus VE will become 0. Then VE will become minus V pi. This is the concept we'll get by KVL. So emitter voltage and V pi will be opposite in sign. These two voltages will be 0. So VE becomes minus V pi as a KVL. Next if I apply KCL at the emitter node point. This is one current, and this one current is leaving. So you can write here V pi by R pi plus GM into V pi. These two currents are entering. One current is leaving, VE by RE. So like to simply write one KCL. At emitter, I'm writing a KCL KCL here. One current, another currents are entering, one current is leaving. But we know that V can be represented as minus V pi in the class. V can be written as minus V pi. Therefore, V pi by R pi plus Gm into V pi is equal to minus V pi by Re. So I converted the total parameters into V pi knowledge. Then if you take V pi common here, it will become 1 by R pi plus Gm plus 1 by Re. This total value is becoming 0. Now you have to understand the mathematics. This total term has to become 0, he said. That means maybe this total term is 0 or maybe V pi is 0. Any one case has to become 0 to satisfy the equation. But common sense you have to use 1 by R pi Gms will come from biasing circuit. So without biasing, we cannot speak amplifiers. That means Gm cannot be 0. Any non-zero value will be there. Any one value, Gm if it is non-zero, I can say that this quantity Re is also non-zero here. So this quantity cannot be 0 in the class. This cannot be 0. Capital R is there and Gm come from biasing, R pi also will come from biasing, beta Re. So I think this total term 100% sure they cannot be 0, these quantities. If they cannot 0, then automatically only V pi can be 0. This is the way how you have to understand the concept of V pi. V pi can only become 0 then. If V pi becomes 0, then the current source Gm into V pi also becomes 0. This also will become 0. Then what is the circuit behavior in the class is? It became open now in the class. So your Z naught dash will become open means infinite. Okay. Your current source is open here. Current source is open. So finally we got the answer. Z naught dash is infinite we got. That means inside total is infinite. Now what is the output impedance seen from the load? Seen from the load. Output impedance seen from load. From RC. If anybody wants this answer now, Z naught will be equal to RC parallel to Z naught dash. So output impedance will be equal to only RC parallel to infinite. So Z naught will be equal to only RC. I think finally it has given a result that Z naught will become RC. So whatever the previous topic we have studied in bypass, the same answer we are getting at output. That means what I understood is whenever you go for a closed loop system electronics, input impedance will change but output impedance will not change. Output impedance we are getting same answers. So this is the important information I can tell you why Z naught will take RC in the classes. RC before it is infinite. RC if you consider here, it becomes RC parallel to RL. Okay? This is only assumption we have done here. We assume, to find out this answer, we assume RC is infinite. After that you just connect RC parallel and see that answer. It is infinite parallel to RC, the answer will become RC for you. So this completes my second proof for you. That is output impedance, what happened, we have understood. So now you can say that this output impedance RC is same as common emitter bypass amplifier. We got the same result. Common emitter bypass, how you got the result? The same result we got here also, Z naught is RC. So only one value is changing, that is input impedance is changing. Output impedance is remaining same. Let us say the voltage gain will be affected or not. That is my next interest. Concept number 3 is voltage gain, whether it will affect or not. According to me, definitely it will affect because we applied negative feedback. Whenever negative feedback is applied, voltage gain will reduce. How much it will reduce, I have to prove now. That will be the step number 3 we complete. So please complete up here. Yeah, parts of the GM the story, मैं बताता हूँ, don't worry about that. You're telling alpha by Re, but I'll tell you what is the meaning, how it came. I'll explain you the trick. Why it is called 1 by Re, I'll show you. Z naught is RC. You complete up here. Z naught is RC. Thus here, whenever V pi is 0, Gm into V pi is 0, Gm into V pi will be 0 or not? Or V pi is 0, either condition, because this quantity will become 0, this quantity cannot become 0, you said. When V pi becomes 0, Gm into V pi also becomes 0 or not? So Alka, I think why this quantity is not equal to 0 means, simple reason. Your Re, simple reason, Re is not equal to 0. You should have common sense here. Either Re 0 nahi kiya na, unbypass mein. Re is not equal to 0. When any one quantity, if you can prove that it is not equal to 0, definitely the quantity will be non-zero. Okay, Re is present here, that's why it is not 0. Re is not 0, my friend. That's why the quantity cannot become 0, I said. So finally, this is the story about my second point. So Ananya, again, क्यों बात कर रहे हैं इसे? A quantity 0 नहीं है, then again mathematics satisfy करने के लिए, any one quantity should be 0. Only V pi is there. The other quantity is fixed quantity. We cannot change it. But only V pi, if you make 0, only that equation will become 0. Simple mathematics here. Why V pi we consider 0? How can you ask like that? Here clearly explain कर रहा हूँ ना. इधर non-zero बोल रहा हूँ, then A 0 हो जाए ना, output equation 0 हो जाएगा. थोड़ा use करो mathematics. Okay? So can I expect up to here? We completed the output impedance calculation is completed. Slowly I'm teaching step by step and take so much of time to understand each derivation. Okay? So summarize why GM is not 0 means GM is nothing but 1 by dynamic resistance. Dynamic resistance depends on the operating point. So operating point comes from the biasing circuit. So this amplifiers will have biasing. You have seen in the previous topic, we have biasing or not? Okay, biasing, you know, whenever you have biasings like this, GM cannot become 0, GM will be having some quantity. Because I Q by VT is GM I said in BJT classes. Okay, that's why GM cannot be 0. So if you complete up to here, let us move to the concept number 3. Very important derivation called voltage gain, how to solve is the most important concept now. Shabni thus, why at the Z naught dash calculations, why this is considered to be infinite is, I consider this as a load, my friend, load. So what you said the condition is, input should be 0, load should be infinite, means you just open this load. Before that I'm finding the impedance. After completing the Z naught dash calculation, I'll just connect the load and I'll tell you the overall impedance that has been covered at the final stage. Okay? Yeah, Majender, directly by seeing also we can tell V pi is 0. Okay? Because no voltage at the top and bottom we can say, but mathematically I'm explaining the content. Okay? They're all helpful for your conventional derivations also. Maximum conventional people will ask you this type of derivations. That's why I'm teaching step by step each concept how to apply it. So let us see the very important step now, voltage gain. Next observation is voltage gain, which is called AV. Very interesting form like this. Try to see how to get it. We have one more time. I'm drawing the circuit to understand better. This is RB. This is VIN. Here we have R pi. This is base. We have current source. GM into V pi. GM into V pi. This is your RE. This is your RE. And this is collector point. And finally we have the load. So you are seeing the concept like this. Carefully see the concept now. Can I take the input from here to here? This is input. From top to bottom is input. This is your output, but this current is going in this direction, which is your plus minus, which you can say this is a I naught current. Your I naught current. So what is the output answer? Here V naught is equal to minus I naught into RL is the answer. It's a negative answer will come because the current is going in this direction. So minus I naught is GM into V pi into RL will become your output voltage. This is your V naught. So what is input here? If you see, if you want to write input here, input is this becomes IB. If you want this current, it will become 1 plus beta times of IB current, which is your IE current. So we can write input voltage as IB into R pi plus 1 plus beta times of IB into R. And just write input output seeing the port. What is output voltage and what is input voltage? If you write output voltage, input voltage, now just IB should be cancelled in the formula. So what I'll do is output by input will take the ratio. Here V pi will write like this minus GM into what is V pi here? This is V pi actually. V pi. V pi can be written as IB into R pi. You can write this quantity as V pi. This is V pi. IB into R pi into RL divided by, you take IB common. It becomes R pi plus 1 plus beta times of RE. So nicely IB, you can cancel it. See the simple derivation. शब्द ऐसे कंफ्यूज नहीं होना यार क्यों आप ऐसे कंफ्यूज हो जाते पूरे टॉपिक्स में ये आरसी को जस्ट वी हैव रिमूव्ड इट आरसी इज देयर when you are solving this side आरसी को थोड़ा टाइम को disconnect किया circuit से that's why we are assuming that the load is infinite because we are not solving from here we are solving from here when you are solving up to that point leave that resistor is telling afterwards you can connect it so here I removed it and here I connected it when you connect it it became RC parallel to inside impedance that inside impedance I found it as that much and why you are talking again this RC infinite there थोड़ा rules apply करो यार RC infinite is a word we have used first for removing it because before that I am solving it now we want after that we want the answer that means if you go back again actually we are solving here this resistor is not counted but now I am solving from here this is RC this is infinite parallel to RC it will be RC that I said in the class okay don't get confused here with the simple things so this is about your concept so what is V naught by VIN answer is it is minus GM into R pi into RL divided by R pi plus 1 plus beta into RE so you are getting the gain like this if you want to make it as a good formula for this good structure if you want do it some more simplification minus GM into RL here RL means here according to our class it is RC here don't get confused this is RC my load is RC here so minus GM into RC keep it like that divided by this R pi you keep it down R pi by R pi plus 1 plus beta into RE divided by R pi to get a good shape I'm doing the simple mathematics this will become 1 here and this R pi we can write as 1 plus beta times of RE I said this quantity we can change it to RE model parameter R pi को हम लिख सकते हैं 1 plus beta times of RE in next step में लिखता हूँ minus GM into RC divided by 1 plus beta into RE. Yesterday class I told you R pi theory we can convert into RE theory. RE theory we can convert into hybrid theory by a technique called HIE is equal to 1 plus beta RE. 1 plus beta RE is equal to R pi. So you can write like that 1 plus beta into RE. So this quantity I replace with this quantity. So theories I have changed R pi to RE theory. So can I cancel this 1 plus beta. Now you can see a simplified answer. It is minus GM into RC divided by 1 plus GM into RE. A very interesting formula throughout analog electronics. So are you seeing that minus GM into RC is our previous class? Where RE is 0. That's why this quantity will become 0 there. But now present situation is closed loop amplifier. That's why RE is present. We are getting an extra quantity in the denominator 1 plus GM into RE. Here 1 by RE. Here 1 by RE I have written there GM. Now I am going to prove that why GM is equal to 1 by RE. Always I take in my classes. This is the right time to explain for you. I'll explain it. So take this quantity 1 by RE. We have written it as GM into RE. So this quantity we never forget throughout the classes because the next topic is active load concept. There are number of times this formula we are going to use it. That's why it will register in your mind automatically. So one time active load concept we will understand. The grip level will increase about these two amplifiers. Let us see in the next module. Your grip level will increase automatically with these techniques. So Rahman, one thing I want to tell you, whatever the transistor gain you found here is equal to amplifier gain here because source resistance RS is equal to 0 we have taken. In all these questions we have not taken internal resistance. Okay, internal resistance of nil either. If this RS source resistance, who will say 0 in the problems? We are not taking any source resistance for your signal source called microphone. Automatically this transistor gain will become your amplifier gain. This is a transistor gain actually. Okay, this is related to transistor gain but it became amplifier gain here. It's called transistor gain but became an amplifier gain because RS source resistance is 0 here. Yeah, Roy, one more time I'll repeat that story if you want. Why GM is not considered to be 0? Some more students are asking same doubt. Let me explain in a brief manner. GM proof I'm teaching there, I'll explain you that point. Okay? It will be clear, Roy? No problem. I'll clear it. So I think, Samresh, if you have not listened to my previous class, you'll get trouble for every step in the classroom because yesterday we had done a lot of time to understand the models. If that models you are not understood, yes, depth will come doubts definitely. You can't understand this class much easily. If you don't have that background knowledge, that's a sincere advice. One time revise that video and come to this video. It's better for you. Otherwise, unnecessarily, every time I have to teach each and every step I have to repeat for you. Okay? It will waste the time. So please try to understand it. You just start revising the previous video first, then come to this video. It is better for you. एक थोड़ा videos को आज ही cover कर दीजिए, so that tomorrow it will be a continuation for you in the classroom. So V0 by Vn is equal to minus Gm into Rc by 1 plus Gm into Re. Let us keep this formula highlight. We never forget this formula throughout our amplifier techniques. Very beautiful formulas. Your V0 by Vin is equal to, otherwise we can write gain formula. The gain formula is minus Gm into Rc divided by 1 plus Gm into Re. So this is the most important formula for unbypass amplifiers. This is for common emitter unbypass. And the AV formula you can recollect previously, we got only minus Gm into Rc. This is the formula for common emitter bypass. So nothing to have a hard practice here. Very simple things to remember and recollect. Swati, I think yesterday lecture has not uploaded. Let me see in my mobile. Previous lecture. Why they have not uploaded? Every day they will upload it. So please complete up here. Yes, Swati, I think it is uploaded, my friend. I think maybe night or morning they have uploaded. So now it is showing 38 videos. So the last 3 videos are uploaded. Lecture 1, part 1, part 2, part 3. Okay, now you can see the mobile. It is uploaded now. Yesterday lectures, maybe in the midway of night I think they are uploading because it takes a time for us to upload it. 3 to 4 hours at least it will take time. So it is uploaded. Recheck Swati, एक बार recheck कर दीजिए. In my mobile also it is coming. I am seeing every day I will check actually whether it is coming or not. If any problem comes, I will rectify it. Yeah, night it is uploaded. Okay, Prashant, let's see Monday onwards. Let's see. The timing will decide. No problem. So write on this formula. By seeing this you can tell. The gain AV is high. For the case of open loop amplifier. Open loop amplifier, the gain is coming high here. In closed loop amplifier, the gain is less coming because it's a negative feedback. So one amplifier is telling I give less gain, one amplifier is telling I give more gain. One is telling less gain, one is telling more gain. This is the situation we are seeing. Less gain and more gain we are getting. So I think I'll give some idea about GM now in the class. Why GM is equal to 1 by Re? A small trick I want to explain. Okay. This is the last line what I have done here. Samresh. This R pi came down here. R pi is cancelled 1. 1 plus beta Re by R pi I have written. But R pi in our theory will write 1 plus beta Re, but you don't know what is 1 plus beta Re. You have not studied it. Then how can I explain it? Yesterday I have taken a lot of time to give this theories actually for the students. Okay. Maybe that is the reason you are not understanding this conversion I am expecting. It's a very tough topic here. First link if it is not there, you can't understand this class actually. So let us go for the previous video. But study point to point we will get. From that, these conversions we are doing very easily in the classroom. Who has studied my class yesterday, they know all these things now. Okay, by mistake if you have been missed, no problem. You just recording video, but practice the video, it will solve your problems. Okay. So let us see gain is less and gain is coming high. So see here, expression, separately I am explaining this, expression for expression for GM. Somebody is asking GM, how to write the expression. First we'll go for R pi theory knowledge, first we'll see, because GM is created in R pi theory actually. From R pi theory we got this GM. The model I explained in previous classes, this is R pi, we have here GM into V pi, and we have the collector, this is base, and this is emitter. This is called as R pi theory model, which is called approximate model in the class, correct? Now what is GM I said in R pi theory is formula. This is V pi, and this current we'll take it as IC. You can see GM formula I said is output current by input voltage. Output current by input voltage, we call it as GMs. I think everybody will agree with this point. GM is transconductance. Conductance is nothing but trans means transfer characteristics. Output by input. Output is current, input is voltage, that is GM. I have that knowledge in R pi theory. But how to convert this into 1 by Re technique? That technique actually. IC by Vi, we are seeing in the board. So let us write this formula as IC divided by V pi. Can I take this current as IB? You can write it as IB into R pi, you can write. IB into R pi. So IC by IB, we can write it as beta divided by IC by IB is current A, beta divided by R pi. But R pi, we can write it as R pi only will write. But if you convert the R pi theory to Re theory, I am just converting it. R pi theory, conversion to Re theory. We got a golden links in yesterday class. Don't forget this I said. R pi can be written as 1 plus beta times of Re. So whatever you are talking here R pi, in Re theory it is 1 plus beta times of Re. Okay? Okay, and from this, let's see all these timings, all these things we'll see afterwards. R pi theory, the conversion to Re theory, R pi is equal to 1 plus beta times of Re. You can write like this. R pi is equal to 1 plus beta times of Re. So let us put here 1 plus beta Re को हम लिख सकते हैं approximately beta Re. So without writing 1 plus beta, you can write as beta Re because beta is always much greater than 1. Beta is a high value, so we can neglect it. So GM, we can write it as, it is beta by beta Re you can write. This R pi, we convert it as beta Re. So beta will be cancelled. So this is my beautiful proof for you how to understand a GM is equal to 1 by Re. From one theory to other theory, nicely converted it. But these are the secrets generally happens. When I want to convert GMs into Re theory, we get the answer is 1 by Re. So now onwards, should not have any doubt that GMs are 1 by Re. क्यों लिख रहे हैं आप? You can see the proof also there. I think somebody asked yesterday this doubt. It is reaching to you, I'm expecting. Divya Das, I think, he's asking this doubt. I think it's clear now. Not only for him, most of the students have this doubt. So this is a beautiful proof for that. And one more question asked by some student that, sir, how GM will not be 0? GM Q is 0 what that means. GM formula is ICQ divided by VT. Now 1 by R is nothing but VT by ICQ. If you reverse it, it will become ICQ by VT. Okay? ICQ by VT. Then ICQ will generate from ICQ will generate from biasing circuit. So GM cannot be equal to 0. So ICQ definitely will come, biasing will be there in amplifiers. If biasing is there, then automatically ICQ will generate. If ICQ generates, GM will come. So GM cannot become 0 in amplifiers. Nobody can get GM 0 throughout your life, because for any amplifier, the main condition is biasing. Without biasing, how can you speak GMs? Okay, GM will be there. That is the reason. To create GMs, we need biasing there. GM is telling about the physical strength of your amplifier, because the gain formula is GM into RC. If the GM is very weak, your DC analysis is very weak, GM will be weak. If the GM is not stronger, you will not get the gain more. That is the physical meaning of transconductance. You should have good GM means you should have good biasing with a good energy or DC energy. So you get good amplification. So please write down up to here. Yeah, Shobik, definitely. At the end of the concept called short notes, I'll explain out here. In the short notes, I'll give the complete package in a single steps. That package we will study whatever we have done the hard work from yesterday to today, just half an hour or 45 minutes. You'll get the complete view in one single screen. Okay? That concept I'll teach you in the short notes when I'm doing my workbook problems. You know my style. When workbook starts there, you'll see the short techniques. At this level, you study each and everything in brief. Okay? At the end of the point, it will be easy to recollect all the points in short notes. At this point, take patience to understand each and every step like this. At the final, I'll conclude each and everything. Don't worry. These all things will come as a recollection for you. So with this, friends, we completed the three characteristics: input impedance, output impedance, and one more is voltage gain. Lastly, there is a current gain also. What is the difference between yesterday class to present class? What is the formula changes? Current gain. Just to give you an idea for you. Current gain, a small logic I'll tell you to finish that one. So please complete up to here. Tomorrow is morning class only, don't worry. Tomorrow 9 o'clock I'll start the class. Sunday class is morning 9. I'll start the class not at 8 o'clock. Okay? Morning class only, don't worry. So if we complete this part, let us see. The final conclusion is current gain, how to analyze. Current gain, which is called EI. So first we will recollect the current gain formula. Can you recollect for common emitter bypass is minus beta into your RB by RB plus R pi. You got some expression like this in previous topic. It's a current gain into this ratio. This ratio is nothing but a current division rule I said. IA to IB, there is some current division rule at the RB resistor and RB resistor. This is a trick we have been practiced for the case of bypass systems. This is a trick for bypass. Whenever the question comes in bypass, this formula wise, you can finish the concept. No need of writing the models, all these things. Straightforward answer, you can do it. Okay? Yes, by tomorrow, Akash Mitra, tomorrow amplifiers will be completed. By tomorrow, we'll reach the concept. And current gain, what is the formula here is minus beta, you take the same answer. RB, you write same. Here also RB, same. But here, it is not R pi, it is having some extra impedance we got. R pi plus 1 plus beta times of RE. So this is the difference between these two formulas. Here R pi is the input impedance. Here your R pi plus 1 plus beta times of RE is the input impedance. This we call it as a ZB, we can say. Impedance at the base will change. So this is the concept of common emitter and bypass. So why can't you have the trick like this without doing the total stories? So this is a story change. Current gain I will not take much importance in my class because it's a small shortcut trick for us. Straightforward you can answer it. So with this, nicely I have completed the total situation in the class. Only one thing is remaining is one special topic today. So whenever early voltage is considered in common emitter amplifiers, they'll ask you calculate the output impedance of the circuit because input impedance will not change today when the VA equal to infinite, and gain will also not change because you will get a very high impedance. So very high impedance parallel to RC will be RC only. So voltage gain will not change, and your what you can say your input impedance will not change when early voltage is not equal to infinite. Only one parameter will affect, that is Z0. How to find that Z0? This type of question generally they ask for gate examiners, they ask directly. So if you do derivations like that in exams, it takes a lot of time for you. One time I'll do the derivation, and the result how to keep in mind is very important because most of the times emitter degeneration circuits will come, which is in current mirrors I have shown you. At that time you don't have the knowledge how to write Z0s. Now at this level we are getting Z0s in the board. So just recollect the point, how to practice it. I'll explain you the proof for you. A very interesting proof which you have to remember throughout the analog electronics. A golden formula I can say. So last conclusion I'm giving. That is common emitter and bypass. You can take same common emitter and bypass amplifier. But the concept here is early voltage is not equal to infinite. Whenever this concept comes, don't worry. The input impedance, ZIN, and voltage gain, AV, will be same. You don't worry about these two parameters. Will be same. The output impedance, Z0, output impedance ZX you can write otherwise. The output impedance ZX you can write some value. The output impedance ZX calculated from emitter, sorry, calculated from collector, seen from the collector otherwise. ZX seen from the collector from the collector is different compared to VA equal to infinite. So this is the only extra concept we are learning in the class. It's a very important step for me, so that straightforward exams, 2 marks questions I can solve directly. I tell you the trick how to remember the formula. First we'll prove it. How to find out this ZX seen from the collector, which is different from the compared to VA equal to infinite. Okay? VA equal to infinite, what is the ZX value we got in the classes? Infinite we got directly because current source is open there. But here what is happening? So actually we got ZX, we got it as infinite when early voltage is infinite. We got like this answer. See from the collector it is infinite. But now whenever I take this effect, what happens? So let us start analyzing the concept. Output impedance when you are solving, you will get a ground here. Next we have R pi. Next we have current source. Gm into V pi. The only thing is here, one extra R0 will come here, R0. And we have some RE. We have some RE resistance. And we are taking here output from the collector. He is asking you, please calculate the ZX. With this current you will take it as some I0 current. And this voltage will take it as a testing voltage, V0 voltage. So what is the ZX here is V0 by I0 we have to solve. When you are solving that, my first rule is my input signal should be grounded. Load should be open. So we are finding like this the concept. Parthosarathy, nothing to derive, nothing to apply. Logic I'll tell you at the end. You'll feel more energetic to answer that question with shortcut trick. Okay, beautiful tricks I'll explain, don't worry. First get the imagination, each term kya hai, first understand it. At the final step I'll tell you how to get the trick. Straightforward how to answer the questions. Ek logic batata hu. At this level try to understand at least the formula so that I can recollect the formulas. So he's asking ZX from here. You want to find out the ZX. So can I have this is V pi from here to here, and this voltage is VE voltage. We have a KVL here again. KVL at input loop. KVL at input I am applying. V pi plus VE is equal to 0. So VE we can write as minus V pi. This is the KVL at input we completed. Same thing happens here also. Okay, same thing will happen. Yes, Anupam, thus current gain will also be same. So no need of current gain also. Input impedance is same, voltage gain is same, current gain also you can say. And current gain will also be same. Because in the formula we don't have any output parameter effects. Input only we have, so formula will not change. Only our interest is output impedance will change with your R0 effect that I am observing in the class. So VE will become minus V pi. Up to here, same knowledge I got. Now if I apply here at emitter point, if I apply the rule, that is KCL rule, there is one current is going here, that is V pi by R pi, one current, which is base current. And one current will come here as I0. You can see that this current is dividing into two parts, and again it is coming same as here. So the two currents will merge and it will come same, I0. And this current will be V by RE you can take. So you can see one current is coming, another current is coming, one current is leaving. So apply the KCL again. KCL at emitter point. At emitter point, it is V pi by R pi plus V pi by R pi plus V by RE. Sorry for that. This is not V pi by RE. V pi by R pi plus I0. These two currents are entering. The leaving current is V by RE. So these are the KCL, simple KCL applied. The two currents entering should be equal to the current leaving. These two currents are entering, this current is leaving. Now you can change V in terms of V pi. You can write V pi by R pi plus I0 is equal to minus V pi by R. Just in place of VE, write it as minus V pi in the class. So you can take common, we are getting some relation now. V I0 is equal to minus V pi into 1 by R pi plus 1 by RE. So previously this answer became 0 actual, but now this answer is coming in the problem. Okay, this answer is coming here. So can I make this quantity comes down, minus V pi can be represented as I0 into R pi is coming parallel to RE. So this is the relation I found between I0 to minus V pi. We got a relation by using KCL. Now finally we can finish the answer. We got a relation between output linked to input parameter. Just finally what I do is, just I'll apply the output voltage derivation now, straightforward. So what is output voltage here? V0 output voltage is this current I want, this current. This current will be how much? Means this current minus this is total current, you have to subtract this current. So it is I0 minus Gm into VGS. So subtract current you have to subtract from the total current, you will get this current. So we can write I0 minus Gm into VGS, this one current, into that R0 will give this drop, plus this drop we want, plus what is this drop here? It is a VE voltage. So this is the way how I have written the output voltage in the board. Okay, output voltage I have written nicely. This voltage drop plus this voltage drop I have written. But you know that VE can be written as minus V pi. So you can change it again. I0 minus Gm into VGS into R0 minus V pi you can write. VE you can change it as minus V pi in the class. Now what is sorry, it is not VGS here. Here VGS I am writing, sorry. Here V pi you have to write. V pi. This is V pi. I have used the language of FET here. V pi you have to write. You write V pi, not VGS. Okay. So what is V pi? We have some knowledge here about this parameter. So apply this one. It will become I0 minus V pi. If I leave it, it will become plus Gm into I0 into R pi parallel to RE into R0 plus I0 R pi parallel to RE. So like this you can have the total expression. Just wherever minus V pi, you throw that value to I0 expression. Can you see that I0 is coming common in the board? I naught is coming common here. So you can write it as V naught is equal to I naught common, which is now R naught plus GM into R naught parallel to, GM into R naught, R pi parallel to RE plus R pi parallel to RE. You are getting some term like this. So what is ZX answer is V naught by I naught is equal to, write in a correct order. First you write R naught, next you write R pi parallel to RE, next you write GM into R naught, RE, R pi parallel to RE. So this is the style of writing ZX answer. Your gate examiners can give options like this and they'll ask you what is the ZX value. So it is at this point it is required to practice this formula. How can we recollect immediately whenever the concept comes with RE effect and with R naught effect? This practice I'll show you. Just a shortcut trick I'll tell you. Let us see how I can recollect this formula in a good manner. I'll show you. So please complete up to here. It's one of the best formula I can say in analog electronics. Your analog engineers never forget this technique. How you'll recollect instantly is important. Without doing this much derivation part, how to recollect is important. So this is a very good formula. You can say this is a very good formula. It's a golden formula to save your time in the coming integrated design points. It's a very good formula. Okay. In coming IC concepts, integrated concepts, it saves a lot of time for me. If I know this formula straightforward, it will help us to do the problems very quickly. That's why at this point we have to practice it. So how to recollect it, I'll show you a trick for it. Okay. Side by trick Patatam. With that we can close this concept. Yeah, Rahman, if early voltage is infinite, R naught will become infinite. But in this case, we have considered early voltage is not equal to infinite. We are doing the proof here. That's why R naught is not infinite here. As early voltage is not infinite, R naught will not become infinite. Okay. Yeah, Akash, previous slide I'll show you. Don't worry. First complete this one. Previous slide I'll show you. Don't worry. Complete up to here. So within 20 minutes I'll give the break for you. Around 10 o'clock, 10:30 we'll start the class again. So please complete this part. Will be completed now. After the break, I think we'll start a new topic called as fifth topic called actual load techniques. Lastly, frequency response. These two contents if we can complete today, we can do the problems based on that. Okay. So give 20 minutes is that we'll face the remaining part. Because when I know PJT class, getting MOSFET class is easier now. No derivations, nothing. Straightforward, I'll tell you the answers for it with this tricks. Only PJT will take time. Remaining things are easy. So please take the derivation properly. If you want, I'll show you the trick here. You can see the trick. You can see the trick I'll tell you here. How to practice this formula. Trick you can see. How we'll recollect it. First write your transistor like this. And keep here RE. And here collector. This is your input. He's asking you from here, please tell me what is ZX. Such that early voltage is not equal to infinite. Examiner will give model like this. Just they'll show you like this. Simple transistor they'll show you. They'll ask you please tell me ZX. These are the questions will come. Okay, standard questions. How to trick this answer, try to see. Whenever the person said this answer early voltage is infinite, my trick is this one. First I'll write in the board some resistance called R naught. And there is GM will be there due to biasing. And this is RE. This is RE. Not only that, here we have some R pi like this. This is the way first I'll write the modeling inside concept. R pi is there. R pi is there, RE is there, GM is there, R naught is there, VN. So now if you want to do output impedance calculation, we know the trick that input should get ground. This is the visualization I have. Input should get ground. Now can you see the answer? Can you make these two resistance in series? R naught plus RE. You can see here. First is R naught I'm saying one resistance, next is RE. But actually what happened is not only RE is coming, RE parallel to R pi is becoming series to R naught there. Not only this expression, R naught plus R pi parallel to RE. Two our terms are completed concept. R naught plus RE parallel to R pi. Seeing the board only I'm getting it. So the two answers we recollect like that. The last one, GM into R naught. GM into R naught. GM into R naught. Just multiply the two terms. Last term is GM into R naught into this total term. Means what the two resistors, whatever you added, you just multiply it with the GM, transconductance. That will complete the task. So you can see the trick R naught plus RE parallel to R pi plus GM into R naught into RE parallel to R pi. The trick you can practice like this. Okay, this is the style of practicing this concept. This is the trick here. This is the trick. Like this, you can recollect that much big formula at an instant to answer the question for you. R naught plus RE parallel to R pi into the two resistance should multiply with GM. Will complete the answer. Okay. Let us complete the final task today. That is called the final trick today. That is called MOSFET. MOSFET within 15 minutes will close the matter. So in a single instant, I'll complete all the points. Try to see. R naught plus RE parallel to R pi plus GM into R naught into RE parallel to R pi. A single instant, the problem is completed. Samresh, in the break time, I need half an hour time here. I have some personal work. Okay, I cannot tell you the current gain stories. The current gain formula, how it came. Previous video may create KMI. Just take back, there goes Samresh. Again, you are not understanding my word. Current gain, all these things, class complete KMI. For conclusion, the class, nothing I explained it. So let us come to the final task. Let us come to the final task. It is common source, unbypass. How to write the formulas at a stitch. Don't waste the time for this. See here, lambda equal to 0. I want the answers. So first you write the model simply. This is RG. This is VIN. Next is gate open. Source, VGS. Up to here we have VGS, but VGS ke baad we have RS. From the source we have RS. Next we have current source, GM into VGS And finally, we have the RC. So maybe the model looks like this. This is RT. Maybe the model looks like this. So everything is same. Input is open, but we got some extra RS in the board. This is the diagram. First, you have to practice. Let us see the formulas now. How to write. Arthasarthi, why GM is multiplied means transconductance always come from the passing circuit. Any passing circuit, GM will be there or not. Just GM I kept it. GM into the two resistors I multiplied. That is a practice. Without GM, there is no amplifier here. GM should be there. So first answer, I'm writing. Input impedance, answer is RG. This is RG parallel to infinite. This is infinite. So answer is RG. So this is the input impedance in MOSFET. Second one, output impedance. You know that this impedance, we got it as infinite. So infinite parallel to RT will be equal to RT. Second answer is completed. Concept number 3, voltage gain. The formula is previously you got, otherwise we can solve this one, derivation if you want. AB if you want to solve. First V0 you find out by this current called I0. It is minus GM into VGS into RT. Like this you can write V0. And what is VI here? VIN is from here to here. So VIN can be written as VGS plus. The same current is going to here also. Because no current is there here, same current is going. So I0 into RS you can write. But I0 is nothing but GM into VGS into RS. This is input output. Then you can calculate this answer. Output by input. The answer is minus GM into RT into VGS divided by VGS common. It will become 1 plus GM into RS. GM, VGS cancels. So the gain formula is minus GM into RT by 1 plus GM into RS. See the beautiness. Whatever the BJT formula we studied, the same formula we are getting here also, the gain formula. There it is RC, here it is RT, here it is RE, it is equal to RS. Both formulas will be same. Okay. So this is the style here. We completed all the characteristics. The last step we have is point number 4. Last step is the technique of MOSFET technique. If I take MOSFET with RS, this is VIN. He's asking you from the drain, can you tell me what is ZX? So he's asking the same question to you. But here the concept is lambda not equal to 0. The first step I'm teaching for lambda not equal to 0 technique. So what is the trick I told you? Same trick apply karo. First you will get lambda not equal to 0 means R0 will be there. Due to passing, GM will be there. Now can you answer the question by yourself? Here input should be ground. This is open. Here we don't have anything here. R pi is not there. So what should be the answer? Nicely you can write yourself. Without my help you can write it. What is ZX? Can you write yourself this answer? Let's see. With the same trick, I want this answer. How to write the same type of answer here? First what you will do is R0 will be there. Next RS parallel to nothing is there here. Previously parallel is there. Now you can write these two answers in series. R0 plus RS. Up to here the job is completed. The next the two resistors has to come product. Is to come product with GM. So answer is plus GM into R0 into RS. Can I see that this is the ZX answer? Well, lambda is not equal to 0. So only difference between BJT class and MOSFET class is there R0 plus RE parallel to R pi we have written. But here R pi is not there. Only RS is there. There you have written GM into R0, RE parallel to R pi. Here I have written GM into R0 into RS. It's a cool behavior about the concept. Okay. So this is about your story of common emitter and common source unbypassed techniques. One time I understood the BJT. I think MOSFET is completed. So complete up to here. After the break, 10:30 around I'll start the class again. I have some personal work now, half an hour. Subject work is there. Around 10:30 I'll try to again start the class. So 10:30 to around 1:30 we'll take a continuous class now. Based on active loads we'll complete. Next we'll start frequency response. If it is not completed after the break also we'll complete frequency response. Okay. So this is about your today module. Please try to complete up to here. And one student asked me previous one slide. That is a previous slide something has been missed by one student. Which slide you are asking? Some student has asked me. So please complete up here. If anything you miss by chance, okay, in the recording video also you can see there's no trouble about that. Because I can't understand which slide you want at all things. So please complete this one. So with this I'm stopping. Around 10:30 I'll start the class once again. Okay. The same class will continue by 10:30. So I'm giving the break up to 10:30.